All right, so today we're going to be working on what we talked about, the idea of adding in an a value into our equations. So I'm not going to go through every single part of every single problem, but I just wanted to give you some heads up of how to deal with this. So we're going to start in 45 with the idea of what would the equation have to look like. So they're just talking about single, double, and triple roots again. So for example, in letter A, those are just 3 single roots because it's got just that sort of shape. Letter B should have a single root, followed by a triple root, followed by a single root. And letter C would have a double root followed by a single root, like that on your page. Now, in 46, they're trying to get you to notice the difference between the two equations. So they have two exact same equations. The only thing that's different is a 3 in front of the second one, which is that stretch factor, that a value that we've been talking about since, I don't know, the second week of school. So nothing too exciting other than the fact that 3x squared is going to look different on a graph than x squared because it's being stretched by 3. Now, when you move on to 47, what they're going to ask you to do is look at the equation or the graph and then determine how you can figure out what the graph of the equation will look like by plugging in a point. So that's what they're trying to lead you to at this point. So in part B, they give you an equation with an a in it. So it looks like a x plus 3 times x plus 1 times x minus 2 squared. And then they tell us that it's going through the point 1, 16. So what they're asking you to do is exactly like what we did in parabolas, where you're going to plug in the point, or the 1 for x in each of these 3 spots, and the 16 for y, and solve for a. So if we do that, we get 16 equals a, 1 plus 3, 1 plus 1, 1 minus 2 squared. So 1 plus 3 is 4, 1 plus 1 is 2. 1 minus 2 is negative 1, squared is positive 1. So we have 4 times 2 times 1, which is 8. So we get 16 equals a times 8. So it's pretty easy to figure out that a has to be 2 then. So we have a stretch factor of 2 on this graph. So that's what you're going to be kind of focusing on for the first half of today, is just solving for those missing pieces. So 48 goes into a county fair coaster ride. It's the exact same idea. They give you a point, except this time you're looking at the graph. So we have to first look at the graph, which has this sort of shape for us. So it's got a single, a double, and a single root. A single root at 0, a double root at 2, and a single root at 3. So they're trying to get you to write an equation that would look like a times x minus 2 squared times x minus 3. And then they give you a coordinate to plug in, just like I did up here, and solve. Moving on down, 49 is, again, asking you to create the equation just like I did here and pick a point off of the graph to plug in. Now, part A has a point that's pretty obvious to use. It looks to me like it should be 0, 16, so you could plug that in for x and y and solve for A. On letter B, the point that they don't really give you an obvious point, but what I would use is looking at that graph, it looks to me like it crosses at 0, negative 3. So like I'm using the y-intercept because that tends to be an easy point to work with, and I would just plug that in for x and y. As you move on down through 50 through 53, again, it's just using the same idea and asking you to plug in points and solve for the a values, just like we did with like the water balloon problems and stuff like that. So that's all we're asking you to do in the first part of these. These problems are exactly the same as the ones out of the book. So if you are getting stuck, you are welcome to go and check and see if you can find answers in there.